-1, cosine -1, or sine -1. These are called the inverses, so it's inverse tangent, inverse cosine, and inverse sine. Or, how can I find angles when I know side lengths of a triangle, a right triangle only? Okay. So, the first thing we want to do is go ahead and find the last side. Since we have two sides, the best way for us to do that is using the Pythagorean theorem. So I'm just going to do that on the calculator so that you can see. All you need to do on the calculator is 33 squared plus 56 squared equals, and then take the square root, and we get 65. So we have the last side, which is 65. And you didn't actually have to write anything down, which is kind of nice because now we don't have a lot of clutter. Alright, if we want to find the angle, what we want to do is figure out what the sine, cosine, or tangent ratio is, and then do the inverse of it to undo it. It's kind of like when you take a square root and you want to get rid of it, so you square it. That's kind of the inverse of taking a square root, is to square it. Or if you have a squared number and you want to get rid of the square, the inverse of that square would be to take the square root of it. That gives us just x. And you're going to do the same thing. It's called the inverse tangent, or the inverse sine. So just pick an angle. Okay, let's start with angle A then. And let's just use the original numbers that we had, even though it doesn't matter because this is an exact number, so it's just like one of your original numbers. But we'll just say tangent of A is equal to 33 over 56. So we get tangent of A equals 33 divided by 56, which is, this is the ratio, 0.58928, which gives you 3. Alright, now I told you before not to clear your calculator. And just what do I mean by that? Well, first of all, let's realize that this is kind of like having x squared equals 9. To find x, we're going to take the square root. And since we have tangent A, our A is our variable. And to find what A is, we're going to do the inverse tangent. So we're going to do tangent -1 of 33 divided by 56. Now it's really important that I show you both calculators how to do this. Can I use your pink calculator? Okay, this works just like a Texas Instruments because it is a Texas Instruments. But it's small enough to fit on the screen so you can see everything that I'm doing. Now remember, we've got 33 divided by 56. And you can run that back if you need to see it. Okay, to run this on a Texas Instruments calculator, we're going to say tangent -1. We're going to do it just right in straight order. So second function, tangent, which is tangent -1. Don't put in tangent and then -1. Okay, and then we're going to do 33 divided by 56 equals. And it gives us the angle measurement, which is 30.5. And we're going to do that to the nearest 10. Always to the nearest 10 on these sides and angles. What's the best way to find B? Subtract from 90. So that would be 59.5. That's the easiest way to find B. You could actually do another ratio. For practice, let's do that. This was 65, and this was 30.5. Let's do opposite over adjacent. Okay, opposite over adjacent. Excuse me, opposite over hypotenuse. Opposite over hypotenuse. That's the hypotenuse of the right triangle. So opposite is 56 over 65, and this is so it's sine B equals 56 over 65. All right, now this time I'm going to do the calculations on a Casio calculator. And you kind of do everything backwards on a Casio, so we're going to start over on the right-hand side of the equation. Let me see if I can show both at the same time. I cannot even come close. I could probably do this, though. Yes. Okay, so we have sine 56 over 65. So I'm going to put in 56 divided by 65 equals, that's our ratio. Now I can do the inverse sine, and I get 59.48 or 59.5, which is what we said before. Okay, let's do another one. Rather than find the third side, since all we're trying to find right now is the angles, let's just use the sides that we have and do equations that will help us to find the angles. Let's find the angle of B. Okay, B, the two sides that we have in relation to B are the adjacent side because it touches B, and the hypotenuse because it's across from the right angle. So I have adjacent and hypotenuse. That means I'm going to be doing cosine. So the cosine of B is equal to the adjacent side, which is 36, over the hypotenuse, which is 85. Okay, using the Casio. Remember to find B, I want to do the inverse cosine. Find B. And this is always used for finding our angles. So I've got 36 divided by 85. So I'm going to clear this. And I'm going to do second cosine because that's the inverse of cosine. Forgot what my fraction was. 36 over 85. 36 divided by 85 equals. And it gives us an angle measurement of 64.94. So it'll be 64.9 when it's rounded to the nearest 10. 64.9. That looks about right. Now the easiest way for us to find A is to subtract from 90. Now you could just use what you already have there and say minus 90. It's going to give you a negative answer, but you'll know that that is indeed the angle measurement. The 5 causes us to raise that 0 to 1 and we get 25.1. So we use sine -1, cosine -1, and tangent -1 to find the angles. Let's do another one. Okay, since we're focused on finding the angles, we're not going to worry about finding that last side. And let's just use A. And for A, we have the adjacent side and the hypotenuse. Adjacent and hypotenuse is cosine. So we're going to say cosine of A is equal to the adjacent side, which is 3 root 7, over the hypotenuse, which is 12. So we're going to use the inverse cosine to find out what the angle is. Second function cosine. And then we're going to use 3 times the square root of 7 over 12. 3 times the square root, second function square root, of 7 times, oops, and we want to probably hit equals there. Let me delete that. Oop, I did not delete it. Let's try again. The square root of 7, 3 times the square root of 7. Okay. Let's end the parentheses there. Main error. Clear. This is good for you to see what to do. It's good for me to remember what to do. It's giving me a domain error every time. Okay, 3 let's do this one a little bit differently. Let's do 3 times the square root of 7 equals divided by 12 equals, now that's our ratio, so let's use our inverse cosine, and then we're going to use the second answer button so that it pulls up our answer and gives us 48.59, which is 48.6. I'm going to go through that one more time. Basically what I did was I went ahead and I did this in one piece at a time. You have to be careful because you want to make sure what the calculator does with addition, with multiplication and division, is it does them in order from left to right. So you really can do 3 times the square root of 7 divided by 12, and it'll do this part first, and then it will divide by 12, and then we took the cosine afterwards. What you want to be careful of is if you do cosine of 3 root 7 and then divide by 12, you don't want it to take the cosine of 3 root 7 and divide by 12. Okay, so let me do that one more time for you. 3 times, I'm going to do it a little bit differently this time, square root of 7 divided by 12 equals, okay, and then we're going to take the second cosine, which is the inverse cosine of that answer. That's what the A and S is. Gave me a domain error. Okay, let's do 3. Learning how to use all these different calculators at one time is an interesting venture. And then divide by 12, and then take the inverse cosine of that. 48.5. Okay, now the easy way, 48.59, which is 48.6. The easy way to find B then would be just to subtract. But since we're here, we may as well do, let's find it using angle B, and that would be the opposite over the adjacent. So let's say sine B is the opposite, 3 root 7, over the adjacent side, which is 12. And I'm going to do this one on the Casio. Now you may find yourself in a place where you have, usually you're using a Texas Instruments, but when you don't have it one day and you need to use a Casio, so it's good for you to learn both ways. So that would be 3 times the square root of 7. Whoops. 3 times 7, the square root, equals, divide by 12, equals, and then take the inverse sine, 41.4. 41.40, so 41.4. And when you add those two together, you should get 90 degrees, which you do. Let's see what's over here. Oh, here's another one with a square root. That's good. The square roots are giving us trouble anyway, so. All right, in this case, if we're going to use A, we have the opposite side and the adjacent side. So that's tangent. Tangent of A equals the opposite side. And remember, I'm getting this from TOA over the adjacent side, which is 6. Okay, using the Casio, it's 2 root 7 divided by 6. 2 times 7 square root equals, then divide by 6 equals, and then take the inverse tangent, 41.4. That was 3 root 7 over there. It's over 6 now. These are similar triangles, it would appear. Let's see. 3 root 7 over 2 root 7. Those cancel, so that's 3 over 2. and 12. Oh, that's your hypotenuse. What's the hypotenuse there? That's a 41.4 degree angle. We have the same triangle. These two triangles are similar. Interesting. I wasn't expecting to find that.